Robot is a machine designed to execute one or more tasks automatically. There are many different types of robots. First, robots that resemble humans are known as androids. However, many robots are not built on the human model. For example, industrial robots are often designed to perform repetitive tasks that are not facilitated by a human-like construction. A robot can be remotely controlled by a human operator, sometimes from a great distance. Next, an autonomous robot acts as a standalone system, complete with its own computer called the controller. The most advanced example is the smart robot, which has a built-in artificial intelligence AI system that can learn from its environment and its experience and build on its capabilities based on that knowledge.
The first challenges is new materials and fabrication methods. Gears, motors and actuators are fundamental to today's robots, but tremendous work is already being done will help to develop the next generation of autonomous robots that are multifunctional and power efficient. Next, robots typically are energy inefficient. Improving the battery life is a major issue, especially for drones and mobile robots. However, research is being done to improve battery technology beyond the nickel metal hydride and lithium-ion options currently available. Last but not least, the challenges is in terms of ethics, which are first, sensitive tasks that should require human supervision could be delegated entirely to robots, and humans will no longer take responsibility for failures. Next, artificial intelligence could erode human freedom, so humans will using it in unethical ways.
There are many contributions of robotics in our daily life. One of it is the flexibility with being capable of performing a variety of tasks and applications. Other than that, robotics nowadays replace and eliminate the dangerous job for humans. Robotics also can handle lifting heavy loads, toxic substances, and repetitive tasks. Robotics reduce and prevent many accidents and also saving time and money. In the era of industrial revolution, the manufacturing sector is smartening up with advanced technology. In this context, robotics is playing an important role in automating and streamlining the operation of varied manufacturing units. Lastly, robotics also give a contribution in the medical field. For example, is intricate surgery, such as a prostate cancer surgery. This is because robotics are able to reach and fit where human hand cannot, allowing a greater accuracy.
Robotic engineers are required to have at least bachelor's degree for entry levels in job fields according to the BLS. They typically hold degrees in mechanical engineering or related engineering specialties. Through degrees in physical science and mathematics may also qualify robotics engineers for employment. Laboratory works and design classes are often standard parts of engineer programs. Some schools offer undergraduate degrees in robotics engineering, which teach students how to apply math and mechanics to create automated machines. For more advanced positions, such as in teaching, research, or management, a graduate degree is often essential. Licensure is usually required to work as an independent robotics engineer. To obtain licensure, candidates typically must graduate from the engineering programs accredited by ABET, which is Accreditation Board of Engineering and Technology. They must then pass the Fundamentals of Engineering exam and gain 4 years of experience as training engineers. Aspiring engineers may then become licensed by passing the principles and the practice of the engineering exam. Robotic engineers must maintain their licensure by earning continuing education credits.
Robotic engineers were expected to see some employment growth in the coming years designing and maintaining robots, as well as studying those automated machines and developing applications for them. Architectural and engineering service is one of the primary industries employing these professionals, but they might find employment in other industries like aerospace, agriculture, and mining engineering. Since these professionals can apply their skills to fields from military to medicine, they may be able to find employment in related engineering fields or specialize in specific types of robots.
Job requirements for robotics engineering. Robotics engineer work mainly with mechanical machines in various technological departments. Licensing is required by state for those wishing to work in a higher level position, while those entering on a beginner's level only need a bachelor's degree. Robotics engineer work with computers and automated machines in technology-driven environments. These in-demand engineers have advanced science and math skills and need undergraduate degrees in engineering, mathematics, or physical science. Their training should include hands-on experience in robotics. Higher level robotics engineer need a state license acquired by completing an accredited degree program, gaining experience in the field, and passing 2 examinations.
The robotic engineering job market will go through changes. Here are some of the things to expect this year and in the near future. First, National Labour Statistics predict more growth. The US Bureau of Labor Statistics (BLS) projection shows 9% job market growth from 2016 through 2026 and expect the addition of 25,300 jobs over the forecast period. Second, robotics engineers should keep an eye on telepresence robots. Industry Reports & Co. indicates a market value worth for the telepresence robotics sector of $148.3 million in 2018, with expected growth to $285.4 million by 2024. Third, a skill shortage could help where qualified robotic engineers excel. The combined skill shortage in the robotic and artificial intelligence AI markets could result in millions of unfilled jobs in those areas in less than a decade, and may companies will continue to need robotic engineers in the coming years. Fourth, robotic engineers will help combine the efforts of human workforce with robotics. The successful robotic engineers of the future will likely be ones that can think of other creative solutions to help robotic and human work together safely and help companies meet present demands and scale up as needed.
The future of robotics engineering is in the hands of engineers and must be handled to ensure safety of all people and the reputation of the field. It's impossible to avoid ethical questions. They are important in both manufacturing businesses and research. So how does one define ethics? Ethical actions respect the rights of others and are best for society. Ethics defines what people ought to do to best follow these sets of rules, but ethics is also always changing. So the other half of being ethical sound is constantly examining our personal definition of ethics and to make sure that things we do or create follow those ethics that we find to be reasonable based on solid truth. Ethics and morals are often considered to be the same thing, but in practice have substantial differences that are important to recognize when examining codes of ethics. Morals are what one believes to be right or wrong, whereas ethics are morals with reasoning beyond simple beliefs substantiating them. A code of ethics has been thought through with reasons for each of its statements, whereas morals can be based largely on emotions or beliefs rather than logic, possibly resulting in unethical decisions.